In the lesson on lighting, I suggested that calling GL-enable GL-normalize slows things down a little. And if you remember, that call makes it so that OpenGL rescales our normal vectors automatically to have a magnitude of 1, which is the way that OpenGL needs the normal vectors in order to get lighting right. And this rescaling is a little extra work on OpenGL's part. It slows things down. So if I'm going to explain how we can eliminate the call to GL-enable GL-normalize and speed things up. We're going to be optimizing the spinning cube program, as usual. And I'll just go down to Draw Scene. And you'll notice actually that all of our normals for the cube already have a magnitude of 1. So we actually don't need the call to GL-enable GL-normalize. And if we comment out this line and run the program, you'll notice that the program still works, that the lighting is still fine, as you can see. We run into a problem when we use scaling, when we call GL scale-F. And what I'm going to do is I'm going to change this translation from 20 to 2, and then I'm going to scale the cube by a factor of 0.1. And we want the cube to look the same as before, because we're just moving it closer and making it smaller. But actually, if you run the program right now, you'll notice that the lighting is messed up. As you can see, the lighting isn't right anymore. And why exactly is this? Well, the thing is, whenever you call GL-normal 3F, OpenGL doesn't use these normals directly. In particular, because we have rotations, OpenGL is going to have to rotate our normal vectors. So in other words, the transformations that we are applying to our points affect the normal vectors. But we can't just apply the same transformation that we're applying to the points to the normal vectors. For example, it doesn't make sense to translate a normal vector. What OpenGL actually does is it uses something called the inverse transpose transformation and applies those to the normal vector. And without getting into the details of what exactly an inverse transpose transformation is, the effect is that whenever we scale by a particular amount, OpenGL will sort of automatically scale the normal vectors by the reciprocal of that amount. So OpenGL is scaling our normal vectors to have a magnitude of 10. And there are a couple of ways to correct for this. One of them is just to change our normal vectors to have a magnitude of 0.1. Then, when OpenGL scales all of these normal vectors by a factor of 10, they'll automatically have a magnitude of 1. So we don't even need a call to GL-enable GL-normalize. We can just sort of manually change all of these normal vectors, and all of the lighting will be correct. So let's run the program to see that the lighting is corrected by doing this. And there we have it. Another way that you can fix this GL scale-F problem is just by not calling GL scale-F, by manually changing the vertex coordinates to scale them manually. And this also works. Now, if we scale by a different amount in the 3 different directions, that the manual scaling approach will still work, but there's no obvious way to change the normal vectors in order to correct for the scaling. So that first approach that I mentioned doesn't really work. You kind of need a call to GL-enable GL-normalize if you don't want to manually scale all of the points. And that explains how you can eliminate the call to GL-enable GL-normalize and speed up an OpenGL program.